All right, greetings, scholars. No real announcements. We're rapidly approaching like at least the end of the new content. So this week we worked on section 3.1 exponential functions. So today we're going to be working on the corresponding homework as best we can, and then next week is going to be the last of the new material. As usual, if you have questions, feel free to unmute yourself to get my attention and we can talk about it. If you've emailed me and I haven't responded, just you have to get my attention during class, like before you leave. It's best to just get my attention live and we resolve it here on the spot. Okay, so let's hop over to my math lab. I wasn't able to get through all of these earlier. We're just gonna try. Let me see. Hey, Google, give me a random number between 1 and 20.
11.
It says, the graph of this is translated 6 units left and 8 units up, right? So we have an exponential function. If we're going to go left, that means our manipulation needs to be on the inside of our base function. So that means we need to do what? +4 on the inside? +6 on the inside. So it has to be either A or C, and then 8 units up. So it has to be C. Hey, Google, give me a random number between 1 and 20.
17.
Sketch the graph of this, okay? All right. So we have two manipulations at play here. We have an exponential function where we multiply the inside by a negative and we subtracted 3. So shift the graph of e to the x. So shift the graph of e to the x. Let me see. When x is -3, the corresponding y is 1, right? So that means if we go, let me see if If we go right by 3 and then flip over the y, that'll put it in the proper location. That's fine. So like with something like this, you can put whatever manipulation thing is proper and then choose a few test points just to make sure that it's matching up, right? So we went right 3 and then we flipped over the y. So then when x is -3, the corresponding y is 1, so it matches up, right? Okay, I'm just gonna go with this. Okay. Do we want to graph this guy? So my exponential tool is third row left. I'm clicking randomly on the chart. We said we reflected across the y-axis. Okay. Actually, let's move it right first by 3. Or I guess what we can do is we can reflect over the y. Thank you. I know. We can reflect over the y and then just move it left by 3. All right, and that'll have the same effect. All right. Again, just choose a couple of test points just to make sure you're in the proper location. But this is what we should have. And again, I'll check attendance in about 10 minutes for anybody that's coming late. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 18.
Let's see. Use the transformations of this to graph the function. Okay, so we have an exponential function that we basically, notice the +2 is on the outside of our base function, so we just moved it up by 2. So I'm going to choose my exponential tool. I'm just clicking randomly on the chart. And it's just this function, the base is e, and we just moved it up by 2. So vertical shift by 2 units. So it goes up by 2. And that's it. Save and check. The asymptote, normally the x-axis, which is y = 0, serves as the horizontal asymptote. Since we moved it up by 2, now the horizontal asymptote is going to be y = 2. The domain. In general, the domain of an exponential is all reals, right? So I think that holds here. Negative infinity to positive infinity and beyond. Right? Okay. And then the range is the very bottom to the very top. Now, generally speaking, it's 0 to infinity, the open interval. But because we moved it up by 2, now it's going to be 2 to infinity, the open interval. So 2 comma infinity. Infinity always gets the parentheses. And because we have a horizontal asymptote at 2, 2 gets a parentheses as well. That's what I mean by the open interval. Okay. Ho, ho, ho. Sorry, yeah, I got the itis. I don't know. Probably not eating vegetables. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 10.
Use transformations. Okay, so we have two transformations at play here. We started with an exponential function. And again, the recommendation is to work your way from the inside to the out. So first we added a 4 on the inside of our base function. That should move the original graph to the left by 4. And then we added 4 on the outside, so it should go up by 4. So just an exponential function, left 4 and up 4. So my exponential tool is first row right. I'm clicking randomly on the graph. My base is E. We said we went right by 4 and up by 4. So this is 4, and this is 4. That's it. Save. Okay. Yeah, left. I totally did it wrong. Yeah, it's left by 4. Horizontal shift. Yeah, it's kind of hard to do acting like you're sleeping. And I think it's the lunch that I ate. I don't know. Let me try this. Okay, that's fine. Yeah, +4. And I think maybe originally I said left. For some reason I put right, but it's fine. Okay. Oh, the asymptote. So it's gonna be y = 4. I think the real culprit is because we're approaching the end of the semester. So I experience senioritis like every year because I'm just like anticipating those months where I'm not really required to do obligated to do anything. The range is the very bottom to the very top, so that's 4 to infinity, the open interval. Again, if anything is not clear, just feel free to unmute yourself to get my attention. Hey, Google, give me a random number between 1 and 20.
13.
If 18,000 is deposited into a bank account paying 3% compounded quarterly, what amount will be in the account after 6 years? Okay. So I'm going to do my notes here. We're doing compound interest. So the formula is going to be the future amount equals P times 1 plus R over N to the power of N times T. Okay. So we're solving for the future amount. So we're starting with 18,000. So 18, 1, 2, 3 times 1 plus our rate is 3%. So we have to put 0.03 divided by, if it's compounded quarterly, then our N is 4. Then we say to the power of N, which is 4 times our T, which is 6 years. This is what we're putting into our calculator. Thank you. I was getting a little concerned. I thought you might. Okay, I'm gonna try my typing again. I never did find the delete button though. Let me see if I can find it. Give me just a moment. What's that supposed to be? I think it's 6. Here. What? Oh, yeah, maybe that's why. No. I found it. Yes. Okay. All right, cool. So let's do 18. We got 18, 1, 2, 3, parentheses, 1 plus 0.03, 0.03 divided by, which is our M, divided by 4, close parentheses, hat, 4 times 6. 4 replicate 6. Okay. That looks good. Oh, I think we're missing our division there. No, we're good. 18 times. Yeah, I think we're okay. All right, let's submit this result. Round to the nearest cent is 44 cents. So 21,535.44. Okay, 21,535.44. 21,535.44 cents. Okay, and then the interest earned is what? 3,000 or 35,35.44. 35,35.44. Okay, I think that's good. Again, if anything isn't clear, yeah. Hey, Google, give me a random number between 1 and 20.
20.
Okay. So in 1626, an explorer convinced a group of indigenous peoples to sell him an island for $29. If the indigenous peoples had put the $29 to a bank account paying 5%, how much would the investment be worth in the year 2003 if the investment were compounded monthly and continuously? Okay, so it's essentially the same thing we just did. I'm going to try to piggyback off of what's already in the calculator and just adjust my numbers. So it looks like our principal is $29 times 1 plus the rate is 5%, so that's going to be 0.05 divided by m, right? Divided by, if it's compounded monthly, then that means our n is 12 hat to the power of n, which is 12 times the number of years. So if it's going for whatever the difference between 2003 and 1623, so what I'm going to do is just make a mini calculation. 2003 minus W minus 1626. So it'll crunch that number. It'll put the result there times the 2, close off the parentheses, and I think we're ready to rock and roll. Okay. 4283 looks like it's B. 4283. Let's go with B. All I did was plug this into the compound interest formula with the given conditions. And then for part B, because it's continuous compound interest, that means we use PERT, A equals P e to the RT. So then our principal is 29. Let's go here. So again, we're starting with $29 times E. So second S. PE to the rate is what, 5%? So 0.05 times the difference of those years, right? So I'm going to say 2003 minus, oh, that's not minus. Minus is W, 1626. And close. So close the parentheses, double close, and I think we're ready to rock and roll. 4455. Looks like it's D. Okay. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 16.
Okay, we'll do 16. Let me check on you guys in Zoom. Letter B. Let's see. Got a total of this. Looks like somebody came and went. A couple of people actually. I might need to update my attendance. I could track them down. I'll be kind of light for right now. I'll be lax. Let me mark these other gentlemen as absent. No show, no call. All right. Let's keep the party going. Okay. Find the principal that would generate this future value. Okay. So compound it daily. So we're using our compound interest formula. So I'm just going to take my notes here. The future amount is going to be the principal times 1 plus R over N to the power of NT. Okay. Now we want the future amount to be 12,000. And that's going to be equal to, now we're trying to solve for the principal. 1 plus the rate is 7%, so that's 0.07 divided by It's compounded daily, so 365 is our n to the power of n, which is 365 times our t. Time is 11 years. So notice we have 12,000 equals p times some number, right? So if we have p times a number and we want to solve for p, then if we use the inverse operation, p, we just divide both sides by that number, right? So in our calculator, all we're going to do is say 12,000 divided by whatever that number is next to p, right? Hopefully that makes sense. Okay. So let me type, let me see, 12. There we go. 12, 1, 2, 3. Division is m. 12,000 divided by that number. So let's do open parentheses. 1 plus 0.07 divided by is m. 365. Close parentheses, hat, open parentheses. 365 times 11. Replicate 11. Okay. Close the parentheses. I think our parentheses look good. I think we're in the clear. I think we typed it in properly. I can't see any mistakes. Not to say that they aren't there. We're going to go with it. It says round to two decimal places, right? 55, 56, 55, 56, 57. Okay, that's really interesting. 55, 56, 57. 55, 56, 57. Okay. All right. Hey, Google, give me a random number between 1 and 20.
Here's a random number, 2.
Okay. For the exponential function, evaluate 2.5, use a calculator if needed. F of 2.5, okay. So all I'm going to do, I'm going to go to my y equals. I have 5 to the power of 1 minus x. Let me practice my typing. So 5 hat parentheses 1 minus is what, like w? 1 minus x is like this thing. Close parentheses. Okay. Now the variable button, A, B, C, D. I do not know how to find that one. Okay, probably one of these up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me try F11. 6, 7. 7. No, nothing. I'm not really sure what those are. I'd have to find them. So we're gonna go to variables. We want to call in the function we just typed in. We want to evaluate this when x is 2.5. And it says round to 3 decimal places, 0.089. Because after the 9 is a 4, so that means the 9 stays as is. Hey, Google, give me a random number between 1 and 20.
1.
1. Given this function, -2. Okay, so when x is -2, that's going to be 1 over 2 squared, which is 1 over 4. So we're just going to go with 1 over 4. Hey, Google, give me a random number between 1 and 20.
4.
Find the exponential function of this form that contains the 2 points shown below. Okay, we need to take some notes on this one. All right. Ho, ho, ho. Merry Christmas. I don't know about you guys, but I am ready for the holidays. It's kind of lax. I don't have any real responsibilities. I do the best. I kind of go out of my way to just be in a good mood and like just try to laugh with loved ones and family members. Because you don't see them. People are like dropping like flies left and right. No day is promised, no day is guaranteed. So you never know when you're going to see these people again. I had a cousin. This was like maybe a month or so ago. She same age as me. She just woke up. She could not breathe. She called for her husband, and then that was it. Just like that. Nothing. She just couldn't breathe. She wasn't doing anything. She just woke up from her sleep. I was like, man, that's traumatic, man. That's like, every time I think about it, it's just like, a low key existential crisis. I'm like, man, you can just wake up dead. It's like, I don't know. I guess for me, it's like, okay, well, there's no need to trip about stuff. Just encourage people to do the best that they can, because we're not going to be in these bodies forever. Not to say that we aren't immortal in our like spirit form or whatever, in our true essence, but I'm just saying as far as what we're familiar with this consciousness, and I really feel like we're like gods with amnesia, to be honest. So I don't know if I mentioned it to you all or not. I think I mentioned it to my earlier class, but just encouraging you all to watch this series on Netflix called The Good Place. Man, it's really interesting. It's really interesting. It kind of follows these like four humans when they and on their the first episode. It starts with them like waking up in the afterlife. It's kind of interesting. It's a little bit slow, but they have some like interesting like topics or whatever. It just ended too abruptly. There's more I want to say on it, but I'm gonna reshift my focus. Okay, so we want to fit this data to, we have this f of x equals c times a to the power of x. Okay, so we're given that when x is 0, the corresponding y is 6. Okay, so let's plug that in. C times a to the power of 0 equals 6. Now a to the 0 is going to be 1, so that means that c equals 6. All right. Then it also gives us that when x is 2, y is 24. So then let's plug that in. So we said c was 6. We don't know a. We said x is 2, y was 24. If we use the inverse operation, divide both sides by 6, a squared equals 4. Take a square root. Normally it would be plus or minus, but a negative base for your exponent doesn't make sense. The negative doesn't make sense in this context. So we're just going to take the positive result. Positive 2. All right? Okay. So then if we put all this together, our function, our c is 6 times our a is 2 to the power of x. That looks good. I'm at a stage where, I just want to leave some kind of legacy. Like, I just want to leave something that can do the most good for the most people. Now, I mean, obviously, like being an instructor or a professor, you help hundreds of people, at least every semester, right? And that builds up over time. So I mean, I've definitely made an impact as far as society. Like, so many people have just come in through passing through my energy, right? But I don't know. I mean, I want to like build and create and like take care of as many people as I can for as many generations as I can, even if I can't take care of myself. But it's like, I feel like with me in and of myself, I feel like I already have what I need. I don't really need much more. Now I want some things, but if I don't get them, I'm totally fine. Like, I'll be okay. But I just want to try to just try to help out as many people as I can, with me being remote or, not physically here. But, it's like a lot of stuff that we experience right now is because somebody left, they devised a plan and it's still in effect to this day. They're long gone. Like, if you think about the people that wrote the Constitution, or if you think about your ancestors, like, how did you get here? Because they sacrificed and they did things to take care of their children, who in turn took care of theirs and eventually gets here to us, right? So it's just stuff like that, just trying to do my part in the whole cosmic. I don't even know what the word is, right? That's just the stage I'm at. 6 times 2 to the power of x. 6 times 2 to the power of x. 6, come on. All right. 6 times 2 to the power of x. When x is 2, 2 squared is 4. Yeah, that looks good. All right. Hey, Google, give me a random number between 1 and 20.
7.
7 heaven. Let's see. Match the graph to one of the following functions. Okay, so it looks like they started with an exponential. It looks like it's turned upside down. And that really seems to be the main manipulation. It's just an exponential that's been turned upside down. So if we flip it vertically, vertical manipulations are outside manipulations. So that more than likely it looks like we multiplied the outside by a negative, right? So it should be a negative 7 to the power of x. Looks like it's C. I think I'm just going to go with C. Yeah, let's go with C. If you're like not sure, you can choose several values of x, find the corresponding y, and just plug them into whichever one you think is correct and make sure that it all matches up, right? You can just choose a few test points, namely when x is -1, when x is 0, or when x is 1, right? Okay. Hey, Google, give me a random number between 1 and 20.
5.
5 is here. Okay. Graph the function of paper, then choose the correct graph. This is just an exponential function. The only one that's exponential, like for instance, A looks like a cubic function, a cube function, right? B is an exponential, so that's a strong candidate. C is linear, and D is logarithmic. So the only one that behaves exponentially is B, so I'm going to go with B. Hey, Google, give me a random number between 1 and 20. All right, I might just do the remaining. I might work backwards.
Here's a random number, 17.
Okay, so let's go ahead and do 19, and we'll work backwards from here. Maybe we might be able to finish. In 2005, the median price of a house in a city was $115,000. Assume a rate of increase of 6% per year. What can we expect the price of such a house to be in 2015? Let me see. 115, assuming rate of 6% per year. Are we talking? We must be talking. We must be talking exponential growth, like PERT. So I'm going to use PERT formula. A equals P e to the RT. And I know PERT is continuous. I mean, but exponential growth is essentially the same formula. It's just articulated a little bit different, but it's the same formula. Okay, so let me see. We want the future amount after what, 10 years? Whereas, let me see, the median price. We're going to start with, let's do 115,000 times e to the power. The rate is 6%, so we're going to do 0.06 times. It's 10 years later, so we'll just say 10 years, right? Okay. Let's use our calculator. I think this will work. Let's just try this. If it doesn't, we'll adjust. We'll do our 115, 1, 2, 3. E is S, so second S. The rate is 0.06 replicated times 10 years. Close parentheses. Round to the nearest dollar. The nearest dollar is going to be a 4. So 20, 95, 44. 20, 95, 44. 20, 95, 44. 20, 95, 44. $209,544. Nearly double. Okay, so we didn't use the proper formula. Increase the median price for the previous year. Use compound interest formula. Okay, P is the principal rate. Interest is compounded, and T is the number of years. I guess it would just be 1. Let me see. Okay. Let's we'll make that adjustment. So if we use compound interest formula, let me see, we can do the 115. 1, 2, 3. Okay. P time parentheses 1 plus the rate, which is 0.06. I'm going to assume that the interest is applied once per year, so we're dividing by 1, so I'm just going to leave that as is. We're going to say to the power of R, which is 0.06, times 10 years. Okay, so it's pretty much the same information. We just let, wait a minute, not R times T. NT, right? To the power of N times T. So this just needs to be to the power of 10. We need to remove all this. Because our N is 1. Okay, I feel better about this. Okay. 20, 59, 47. 20, 59, 47. 20, 59, 47. 20, 59, 47. Let's try this one. Okay. All right. I think I'm just gonna do one or two more, like no more than 5 minutes worth. Hey Google, give me a random number between 1 and 20.
6.
Okay. Sketch the graph of this by making the table of values. So our base is larger than 1, so that will behave like a normal exponential. But then the negative exponent causes it to be exponential decay. So it should just be exponential decay. It should be either C or D. And then I feel like if we choose a couple of test points to confirm. Let me see. Okay. When x is -1, the corresponding y should be a 1.3. I believe. That doesn't look like a 1.3. I'm going to go with C. One, two, three, four, five, six, seven, 8, 9, 10, 1.3. And that was closer to 2. When I chose a few test points, it looks like C is closer. I just chose a couple of values of x, found a corresponding y. I'm going to go with this one. All right, gentlemen. I think I'm done for the day. Are there any burning questions before we go our separate ways? Well, once, going twice. Okay. All right, gentlemen. If there aren't any burning questions, we're going to go ahead and end the session here. Let me see. Yeah, no real announcements. Just this is a really good time to get caught up with your assignments on My Math Lab. Because once we get back from the Thanksgiving break, I mean, everything is going to be over in the blink of an eye, right? So it's best to just go ahead and get caught up with that stuff now. I encourage you all to collaborate with anything that's on my open math. I mean, my math lab, right? So either work with your classmates or link with the tutors, or either like contact me. You know, just get this stuff submitted. It's best to get caught up now, so that way, once we hit finals, idealistically, you want the final to be the last thing that you submit. So when you're done with your final, you're done with the course. You're not trying to like do a whole bunch of assignments after the final. Also, if you are going back and doing old assignments to boost your overall grade, I would encourage you to prioritize your exams, where that's where you can get the most bang for your buck, right? You can do the least amount of work and impact your grade the heaviest. I would definitely prioritize my homework last, because that's where that's going to be a whole bunch of work for minimal points. The idea behind the homework is really just to kind of get you ready for the exams, right? And again, if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, have a great weekend, guys. And I will see you next week, same time, same place. Take care, guys. Peace. I think, yeah, that's fine. As long as you got your attendance ready, let me see. I think you're okay. Yeah, I got you.